Hello and welcome to this episode of T-Tech. Today we're going to be installing the Nginx web server on FreeBSD. So the first thing you want to do is log in as root. And before following along, make sure you set static IP. I've set one here. And you may also, under etsy.rc.conf, enable NDP date, so you have accurate time for log files and things like that. So we're going to run package, and we want to say yes to install the package management tool. Now you can install this from ports, and that's good if you want to change some knobs around and add features, but we don't need to do that for most installations. Let's do package, update, and package install Nginx. Just say yes to that dialog here, and you can disregard that for most installations, that message. And we want to go to user local etc Nginx. Now we want to back up the nginx.conf file to an original file. What you want to do from there is remove the original, and we'll go ahead and make a new one. Once we're in here, we're going to go ahead and use HTTP as a keyword. Then under there, we're going to put an opening curly brace. And let's enter down a few times and make a second one. So inside of these, we want to make another directive, is what these are called. And you want to make one for server. And inside of server, you want to tell it where to listen. So we're going to tell this Nginx to listen on port 80. You want to end this with a semicolon. And under that, we want to specify server underscore name. And localhost is fine for testing. Then if you have a domain name associated with this web server, you would want to put that domain name. So from there, that's what we need in the server clause. And another clause we need is location. You want location and then slash. Now this tells it where in the file system that Nginx is running on, where the files are that it should serve. So with a location, again, it's another directive, so do make sure you have the proper braces around it. And what we're going to do is put root, and then this is where the file will be, or files, for a website. So we're going to do user local www test, and then end that with a semicolon. And then under this, we're going to say index. This tells it what index files it should expect. So the beginning of the website. If you don't specify where you want to go, this is what it will serve you. So we're going to say index.html and index.htm, and then a semicolon. So that is the main thing we need to tell it to listen on port 80. And to serve files from the user local www test directory, as well as what the index files are. Now, we also need a directive called events. And again, just like the other three there, we want to put worker underscore connections 1024, and then a semicolon. This means how many processes Nginx will create in order to respond to web connections to it. So that's fine. Under that, we want one last thing, and this is optional. I'm going to explain why it's important, though. We want user nobody and a semicolon. So the reason is when a web connection comes in, the main Nginx process runs as root, and then it sees the connection come in and it makes a child process. The advantage is if the child process that's actually getting data from the client, they exploit Nginx and they get a buffer overflow or something, the instructions can start to, run and be malicious. But with this, you don't got to worry about that. So it is by default, though, it runs as www, but we'll see that there. So we're going to save it here. And under etsyrc.conf, let's enable this here, nginx _ enable equals yes, and then have that in quotes. And now we're also going to go into user local www, and we're going to make that directory. There is default directories, but doing it this way, it helps you do things like vhosts and helps you understand it better. So we're going to make a file in index.html, and we'll make a quick HTML file here. And we're just going to say this is a test website hosted by Nginx with a custom config file. And we're going to end our paragraph. And then we'll go ahead and end our HTML. All right. So now we want to do service Nginx start. Okay. This is great. I didn't think this was going to happen this time. I thought I had to straighten around, but we're going to go vi +8 to go to that line. And what has happened accidentally is that the location directive is in the wrong bracket. So let's see here. I go ahead and pause the video and I will fix it and I will explain what went wrong. Alright, I do apologize there. So as I said, to be careful about the brackets in the directives, what had happened was I put the server bracket up here accidentally. You want the server, you want the start bracket of server to be up at the top there, and you want that bracket, the ending one for this server, to be at the bottom here. You want location to have its own brackets inside, but you don't want those to be separate. You want location to be nested inside of the server directive. So it does get confusing, but you just need to make sure the brackets are in the right place and mean what you think they mean. So let's save that now that we've done all that. And we're going to do service Nginx restart. Now, it does have a built-in parsing, and it tests the config file. So the Nginx configuration file is there, what we just made. Its syntax is okay, and then the test of it is successful. And then there it starts the server for us. So let's check netstat.an. It's listening on port 80. Good. So now we're going to hop over to a web browser and check that our website is being served correctly. I'll see you in a second. All right, before we tested it, I actually wanted to show you something important. This is what I meant about the user directive. This process here that is 1569 as root, it's paused, and that is Nginx, and it's made a child process 1570 that's running as that user in that directive, okay? So this is the process that's getting the information from the web clients, just so you understand what that directive does and why it's important. Now we're going to go test the web server. I'm going to go ahead and go to that IP, 192.168.0.1. And then here we go. This is a test website hosted by Nginx with a custom config file. So if we bring back up our machine here, I just want to show that if we go to that directory where we put the file here, and if we change anything in it, like this is, we take out the website part, etc., and save that. and we restart Nginx. As we refresh it here, you see website disappeared. So I just want to show you how you edit that file, and of course how you tell Nginx to serve that file. Alright, so now what if we want to protect the information that our web server is sending to clients? Because right now it's in plain text, so anyone on the network can see what is being said. Well, what we're going to do this is we're going to go ahead and log back in. So remember, we've already set up our one on port 80. Now we're going to do the steps to set up public and private key encryption. So this is SSL, or also called asymmetric encryption. So let's go into user, local, etc, Nginx. And in here, we're going to start by making a directory, Nginx _ SSL. And then I want you to go into that directory. So inside of here, let me clear the screen, we're going to create X509 certificates. Now, we're going to start by the OpenSSL command. So OpenSSL space request, so REQ dash X509 509 for the type. Our hashing algorithm is SHA-256 in this case. And then the new key value, and again, these are called switches to OpenSSL if you didn't know, or flags, and they just change how it operates. The new key type is RSA, and we're going to do a colon after that, and then this is the bit length. We're going to use 2048 bits. Alright, so that's the key length that it can encrypt. So our output, our key out, is going to be ttec.key. This can be for your domain name, for what the server is, doesn't matter. So that's the private key is what's important to know. That only can decrypt the data. And you want to protect this key on any server. Even if you're using this just between two PCs, you want to protect the private key. So after this, we're going to go ahead and do ttec.crt. This is the public key, and this is used for encryption. So together, one key in this pair will hide the information. It will encrypt it. The other key in the pair will decrypt it. So it will reverse the process. And you need both to make a full encryption. Alright? Only for one side, so that the client also provides these. But we don't need to worry about that because that's taken care of in the client. The server is what needs to be configured. So after we've specified those, the last thing we need to specify is days. This is how long the cert is valid for. And after this time elapses, the browser, when you try to connect to the site, is going to say, hey, something is wrong. This is expired. It's not valid after this certain time. Now, quick fact, that can also happen if your clock on your computer gets out of date. So if you do get an error like that, check that too. But that's besides the point. I've run into that quite a few times. So 365, we're going to do a year. And then we're going to say no DES. It's an older encryption standard. We don't want to use it with these keys. So at this point, we can hit enter. Now here, we're just going to say US. I'm going to say test. You don't even need to fill these in, at least for testing. You really should for production. You should put your full DNS name in there. So once you've done that, put in your test, put in whatever you want. If we list the files here, we have the ttec.crt. This, again, is the public key for the encryption. Now, the string here, this is the result of the hash. So the encryption took place. And this is one side that when the client wants to send data, it uses this information and combines it with the data it wants to send. And when it's done running the steps, you have the result of it, which is in the encrypted data using this public key. Now, because it was encrypted with that specific public key, the server that holds this file, the private key, takes the encrypted data, runs it through this private key in its steps to decrypt. So that's the interesting thing there. And that's how they work together. Doesn't have to be a web server. This can work on SMTP servers, web servers as we've seen. It can work on SSH servers, lots of things. So we have our files. So now what do? We're going to go ahead and go back to the Nginx directory. And then let's go into nginxconf. And this is our one where we just set up plain text. Now, make sure it is outside of this server clause. So from this bracket to this bracket, you want a separate server clause. Now, we're going to do server, an opening bracket. This time, we're going to have it listen on 443, and it's going to be SSL. And then the server name is the same way here, and that with a semicolon though. Now we're going to use SSL certificate, and then here we're going to put in user local etc nginx nginx _SSL ttec .crt. That's the public key. It's going to send to clients connecting. Now we're going to use the private key. And then this is this is the part of the key pair that decrypts what the client's encrypted. Now do make sure to put a semicolon on the end of both of those directives. And now, I do believe in Nginx it does have defaults, so you don't necessarily have to set these. But with SSL ciphers, you can specify what the server will allow the connection to use. So we're going to say hi, and then we're going to have a colon to separate it. Now, we're saying with this first one that we don't want to allow null as a there's something called the TLS hello messages that get sent between the server and client when they want to encrypt data together. You can choose null as an option. That means no encryption happens. We don't want that here, obviously, so we want to say don't allow that. And we also want to disallow MD5, because MD5 is weaker than newer hashing algorithms. And we also need, we want to have it here at least. So in this hello message exchange, the server's options are more preferred over what the client tells the server to use. So do make sure you have your semicolons and everything on there. And we do, so make sure we don't miss anything here. Now, those 4 lines, and then the SSL part on listen is the only difference between a plain text web server in this case. So now we're going to say location, and this will essentially mean the same thing as the normal server, so root, and then where we want to say user local www.test, and then where our index files will be. Okay, and that's the end of location. Alright, so that's how it should look. Again, we've already set up the 80, and now we set up our generated our keys, and then we pointed to those keys in Nginx, and of course went on to explain what they are. So we're going to go ahead and save this, and we're going to say service, and I want you to see right now that we're listening on 80, okay? And if I typed everything right and the keys are correct, and I restart. Now, again, this is what I had said about the directives. It messes you up every time. I'm going to go ahead and pause it. Okay, so do make sure that that last bracket on the server directive, you got to make sure to add that. Otherwise, it thinks events is in there. Okay, now that we've added that, we'll go ahead and restart it. And remember, we were only listening on 80. And now with this new configuration, the SSL configuration, we're listening now on 443. All right, so now I'm going to go ahead and pause this, and we're going to show that we have a server on 80 and now a server that can speak SSL and or TLS to the web clients. All right, before we test this, do make sure you put slashes instead of dots in location. I accidentally made that mistake. Alright, so now we're at our insecure web server here. We're going to go ahead and type HTTPS. And I just accepted the dialog, but what happens is that it's a self-signed certificate, so it's not signed by a certificate authority. So we do have encryption. So it is encrypted. So it is encrypted correctly. The encryption isn't any less secure. The reason that it's saying this is because it can't verify who it's connecting to. So anybody can set up encryption. It doesn't mean it is going to be seen as valid by your application. So if we go to certificate, it says invalid. The reason is, remember how we put test in that OpenSSL command and how we made it valid for a year. If we go to details, we can see, there's no real valid information that links back to anything. And certificate path, this test is the only path. So it's the start. All right, so this is like me, hey, I'm this person, but you have no other way of verification from another person. All right, or I get a piece of mail and I can't verify where it came from. Okay? That's why this is happening. And that's also why when you make these, you pay a certificate authority to sign your public key. Because then those signatures are put in browsers like Google Chrome, Firefox, Edge, whatever you have, and they're able to verify that your certificate is valid. But that is what we got going on here, and now it is fully encrypted. So that is how we set up Nginx. We've set up a plain text version on port 80, and we've also set up an encrypted version on port 443. So I do hope you enjoyed this, as always. It's Tyler with T-Tech. Thank you for viewing, and have a very nice day.